Welcome to another Univirtual experience here. This is a partnership and collaboration conference and festival with the Virtual World Society and Educators in VR. And we're bringing together experts and innovators from around the world here to talk about immersive education and how it's disrupting education globally. I am so thrilled that you all are here. This is the end of this is day 5, isn't it? No. Where are we at?
This is day
Mark,
5.
this is Friday.
This is
This is
Friday.
day
This is
5.
Friday.
Oh my gosh,
Yep,
it's
day 5.
gone like just crazy. This is day 5 of this incredible world building voodoo session here with Mark Gill of St. Cloud State University Visualization Lab. That's a mouthful this early in the morning. But before we get to getting on with this amazing last day of this 5-day workshop, um, I want to let you know that we could not do this without the help of many of you here in the audience, our members, and also our sponsors. So I want to thank HP Virtual Reality and HP Higher Education. They are our Infinity sponsors that help make this 30-day conference possible and free and open to the public. They just released the new version of the HP Reverb G2. You need to check that out if you haven't. It is amazing for university and higher ed. It's incredible. We have articles that are on our website at educatorsinvr.com. We're also going to be doing some sessions next week with the HP people to talk about VR labs, the challenges of getting the headsets and everything into the schools, and what HP is doing in the education market. And you're going to just love that. So get ready for that happening. We also want to thank our Galaxy sponsors, Engage and Advantage Education, that are truly changing the face of VR and AR in education. Now, I also want to thank Dana. Oh, I can't even talk all of a sudden here. Donna McTaggart of Let's Meet in VR. She's the event manager and director of events for educators in VR and Univirtual Experience, and Tony Cube Studios for their generosity of spirit in assisting with the video and the live streaming efforts for all of our educators in VR events here in Altspace and beyond, and the Univirtual Experience events. I also want to thank all of our amazing moderators and support team, and everybody who helped make this possible. Now, Mark, you have been spent the last few days, last 4 days, now we're on 5,
Yep.
talking about mind blowing techniques to not just build using Unity, but to work within the confines of AltSpace. And we have heard some amazing rants and rages, and those have been passed on to AltSpace, letting you know. So we maybe hearing some changes coming up in the future on how world building is done. But what are you going to hit us with today?
Today is going to be a little bit scattered compared to the other days because I don't have just one topic that I'm going to talk about. This is going to be a collection of things that didn't quite make it into any of the other days. And hopefully, I see a couple of people that I've in the audience that I've talked to about the worlds that they're working on. Hopefully, some of the stuff that I'm going to talk about will answer some of your questions that I've got.
And one of the ones I do hope you will address is the issue of how to control the FPS, the frame rate. How do we because that is a struggle that we all suffer with. So I'm going to get my question in early so you can
Okay.
store it in your head. But battling frame rate, I mean, has anyone out here been dealing with they think they have the perfect template, the perfect model, the perfect kit item, they bring it in and it says like 30 or 40 frame rate,
Yeah.
and you're like, what did I do wrong? So that would be beautiful. You can add that to your list of questions.
Yep. Yeah,
Okay.
we could. Yeah, absolutely. Speaking of questions,
Okay.
we've got hand raises on, and what we'll do is just once we get like a stack or two or three of them, we'll just pause where we are and address those.
Okay. All right. It is all yours, my friend. Go for it.
Thank you, and let's give it up for Laurel and everybody at Educators in VR because they are doing an amazing amount of work this entire month. I get to take a break after today. Actually, I got another hour of this, and I don't have to worry about it again for a week, right? So, man, this is awesome. This is the fifth day of our workshop. We're going to be talking about putting it all together, and then the only thing left to do is to tour worlds that you guys have created, which we're going to get access to those by sharing them on our Discord server. So I want to plug my Discord server. Um, This URL down here no longer works. I was notified yesterday that it has expired. The discord.me/carnivore will still get you into the Discord server where you'll be able to ask questions. I'm posting stuff that just did not make it into any of these talks that I think need to be in there. Um, and then if you've got some interesting things that you want to show off, you'll have opportunities to do that. It's kind of a continuation of the information that's presented in these talks. So the first thing I'm going to talk about is probably a really important thing. It may help. It may help some of you. It may hurt some of you. In fact, these first few topics that I'm going to cover, occlusion culling, terrains, level of detail, they're things that can help, but they can just as easily wreck your world in terms of performance or frames per second. And the first one I'm going to talk about is occlusion culling. It's a decades old concept when it comes to 3D graphics, and it's basically just not bothering to draw the stuff that you can't see. And in this sort of stick frame representation I've got here, you can see I've got this object that would represent an occluder. This black thing over here represents what would be called the occludee. It's being occluded. This triangle represents my camera down here. So when the camera is in a position where the occluder completely blocks the view of the occluding object, it just removes it from the rendering pipeline. It does not even bother to calculate the lighting on it or the shading or anything, thus increasing performance. Now these things need to be marked static, and objects can be both an occludee and an occluder. And I've got a demonstration of that. So here I've got Unity set up, and I've already gone through the process of baking my occlusion. Oh, it looks like I need to bake it again because I've added a bunch of stuff. So we'll show you how to bake occluded objects. You bake this occlusion data into your terrain or into your template, just like you bake the lighting, just like you bake a lot of different things get baked into the scene, and it needs to be pre-calculated. So I've got all of these different objects that I just sort of scattered around. There's dozens of spheres and dozens of candles and dozens of. It's a pretty heavy scene. Uh, I baked the lighting on something like this earlier, and it was well over 100 megabytes just in lighting data. So these objects are very big, and there's a lot of them. So if I come through here, and really all I have to do initially, there's some controls that I can fiddle with to fine tune the performance of the occlusion, but I just have all of these objects marked as static, and there is actually a special kind of static. I didn't even talk about this week. There's different types of static. Things can be all sorts of different types of static. But as long as you've got this main checkbox checked up here, then they're going to be all kinds of static. But occluder static and occludee static are the two things that need to be checked in order for the occlusion baking to take these objects into consideration. I bring up the occlusion window, which I can get to by going to Window. I think it's under Rendering. Yeah, Occlusion Culling. That will open up this window that lets me, select specific objects. What kind of objects do I want to bring into my occlusion calculation? And then I can bake it, which I'm going to bake this again, and we'll see it. You see it. The engine is going through the entire scene, and it's breaking it up into these little subdivisions, and it's recording the data of which objects are in which one of these cells. And that's how it works. It doesn't really work on the individual objects. It works on these cells. So if the camera is standing in one of these cells, this cell has the information about which all of the other cells it can see. Okay. I'm on air? Okay, I'm on air. So when I visualize that occlusion data, I can see that here's my camera here, and this is all the stuff that my camera can see. And I've even got this camera animated so I can play it, and we can see what happens as the camera moves through the scene. As the camera's moving around, these different cells are being exposed. They're being turned on and turned off. And that limits the amount of drawing that the rendering engine has to do, because the other things, the other objects that are invisible at any particular frame are not taken into account. They don't go into the rest of the rendering pipeline, so they don't have any overhead in that drawing process. And I want to talk about what's wrong with occlusion culling in a minute, because the problem with occlusion culling is the same problem with terrains, which are really really cool. And if you ever get an opportunity to work with Unity in like an actual full game development environment, something for the PC or Linux or a really high end system, terrain is so much fun to work with. It's very, very powerful. And it's used in a lot of 3D engines, right? So if you've ever played something like Assassin's Creed or Grand Theft Auto or some huge open world game, it's a terrain, probably a speed tree terrain, because speed tree is one of the most popular terrain engines out there, uh, that you're sort of moving across. And what it does is it automatically generates levels of detail for all of the different models and all of the detail models and all of the grass and all of the rocks. And a lot like occlusion culling, it only shows you those trees or those blades of grass or those rocks or those features that are closest to the camera. Um, Additionally, it has a way of decimating the terrain data so that the terrain that's way off in the background is a lot lower polygon count than the terrain that's closest to your feet. So you could put incredible details all over the terrain, and you really only have to worry about drawing the details that are closest to the camera. And I've got an example of a terrain set up in this project. So here's a flat Unity terrain, and a terrain is a Unity object type. So the the nomenclatures can sometimes get a little confusing when people are talking about world building and they're making reference to a terrain, right? Terrain can be, in a world building sense, just the geometry that's representing the ground. I can talk about the terrain in my world, and it may or may not be a Unity terrain. It could just be a piece of 3D data that I'm using as a terrain because I've got trees and stuff on it and water, whatever, right? But a Unity terrain object is its own sort of thing, and it starts off very flat. And I'm going to come over here to the inspector so I can take a look at the. Normally, I don't have my user interface laid out like this. It's usually a lot busier, but I'm hoping I'm doing it this way for readability on these screens. I hope that helps. Okay, so the terrain exposes kind of a complicated sort of GUI where I've got different tools. I've got paint brushes where I can paint heights, or I can paint textures. I can paint trees, detail models. And then I've even got all sorts of controls where I can control not only the size of the terrain and the maximum height of the terrain, I can import height map data from, it has to be in a raw image format. And you start messing around with it, and you've got to have the byte order right and the resolution right. But when you've got all these settings just right, I can take a piece of actual real world terrain, say the Grand Canyon or something, Mount St. Helens, and I can bring that in, drop it on this Unity terrain, and it will conform to that height map perfectly. So if I've got a real world setting, if I have the height map for that, I can make a very interesting piece of terrain. I can also sculpt the terrain by hand. So if I go to the paintbrush and I go to razor lower terrain, I've got a collection of different brushes here. I get sort of a preview. See how the tool sort of shapes itself to let me know what that terrain is going to look like? And I can just go all over the place. Opacity represents the strength of the effect. So if I lower the opacity, it's going to push the terrain up less. So I'll make a nice little mountain range swell over here. It's really more of a mound. I'm not. I think this is a really huge piece of terrain, so it probably works out to be a kilometer on a side by default. It's 1,000 units by 1,000 units, I believe. So this is right off the bat. This is way too big to fit into alt space. But something smaller would probably work well. Um, I know Daisy Shaw. Is she Daisy? Are you in here? Yes, you are. Um, Maybe in a minute you could talk about your solitude world because you're using this type of terrain in there, right? Yeah. So the terrain, I could push it up, I could push it down. I'm gonna paint different type of textures on it. Each texture has to fit on what they call a layer, and each layer is sort of like a little material unto itself, right? I can have a diffuse map and a normal map. I don't have all of the controls like I had in a regular standard texture, but I do have quite a bit of them. So I'm going to decrease my brush size a bit, still keep my opacity small, and zoom down into the terrain. And when I get down here close, you can start seeing the tiling of my base grass texture. But now I can paint another texture onto it if I want, say, like a dirt road or a dirt path. I can paint these other textures right into the terrain, and Unity is going to handle blending them together. So maybe I've got, a, a sand texture for the edge of the road and a cobblestone texture for the middle of the road, and these textures can have different sizes, different spacings, different resolutions, and they're all gonna mix together. So a lot of times what I do when I'm building a complicated terrain for a project that's got rivers and hillsides and representations of different types of terrain, I can paint, say, a dark, wet, sandy texture for the bottom of the river, and then dry that texture out as it comes up the slope. And then once it gets up away from the river a little bit, I can put some leaves down and some grass. And then when I get into the trees, it's more leaves and underbrush, and go up the side of the mountain where it transitions into rocks, and finish up with snow at the top of the mountains if I want to. You can represent all of those different types of climbs with a single terrain and a single terrain material. Terrains also have their own kind of collider. So you don't have to worry about falling through a terrain. You don't have to worry about managing the colliders on it because the terrain it's sort of like a mesh collider, but it's really its own thing. The terrain will handle, not letting, as long as it's got this terrain collider on it. I guess I could actively go in here and take it off, but then I'd fall through the terrain. What'd be the point in that? And then I'd have to fix the problem I just created for myself. Trees are another thing that I can just paint. I can load up multiple trees, and I have to get these trees from someplace. There's a collection of trees on the Unity store, but SpeedTree is the company that makes Unity's terrain engine. And SpeedTree terrains and SpeedTree trees and plants are actually used in a lot of different game engines. You can get SpeedTree for Unreal. You can get SpeedTree just of itself, and I can plug it into any game engine that I want. So if I really wanted to write a game in something like Gato, I could plug SpeedTree into Gato and use the same. The interface would look different. The tools would be in different places, but the names and the way they work would all be the same in whatever application I'm working in. And SpeedTree is sort of the industry. There's other terrain makers out there and other terrain engines and tree engines, but SpeedTree, man, if there isn't, if there is an industry standard, I would be surprised if it's anything other than SpeedTree. But I can just paint these trees on the terrain. Maybe my come up my tree density a little bit. There we go. These trees are all procedurally generated, which means they're all unique, right? When I'm selecting one of this tree, really what I'm doing is selecting the type of tree that I want it to be. And SpeedTree allows me to define a lot of different types of trees. The trees itself are they're there's some basic modeling in there, so it puts some textures and some geometry in it, but it's all procedural. So as the engine is coming up the base of the tree, there's a chance at any point along here that it's going to make a branch. And then along that branch, there's going to be a chance at any point along that branch that it's going to make another branch and go all the way out to twigs and all the way out to leaves. The trees are defined by those probabilities. How spread apart are the leaves and the twigs and the branches, and where do the branches start, and which direction do they go? And all of those things go in defining a tree so that Once SpeedTree has its head wrapped around those probabilities, it can create nearly an infinite number of trees that look like the same type of tree, but they're all different. They can also blow in the wind, and they also work with baked lighting and real-time lighting, and they all have their own little tree colliders on them. So I can walk through the trees if I want to, or I can bounce off the trees if I want to. It's it's a lot of fun to play with. Working with terrain a lot of times is my favorite part of the project, especially if I'm trying to recreate a real piece of ground somewhere. Um, it's a lot of fun. Another popular optimization technique that the SpeedTree um, takes real. Oh, something else I should tell you about the terrain. That's really cool. So I'm gonna look over here and I'm gonna look in the wireframe mode, and you should be able to see the density of the terrain mesh. And as I get further away from it, you see how it's popping and changing. And way off in the distance over there, I can see that there's actually very few polygons being used to define that terrain. Well, those colors are atrocious. It's not very easy to see that. And then as I get closer and closer to the terrain, you see there's very broad polygons here, but in areas where the terrain needs more definition. Oh, and here come the trees popping in. So it doesn't bother to show you the things that are too far away to be seen anyway. And all of these different levels of detail are generated by SpeedTree. It calculates several different levels of detail for each of these models, and eventually renders out a picture just of that model. And at the furthest detail, that's all you're seeing right before they disappear. Like right about there, there's no shadows or anything on them. That's just a picture of that tree. And if I go a little bit further away, it's going to go away altogether. I said, it's going to go away altogether. I said, it's going to go. Maybe it won't. Maybe there's got to be a distance. It would. There's got to be a distance. Anyway, leading back into level of detail, right? So the concept is that I have a high detailed model where it's I've got all my nice sparkly material effects and my super high resolution normal maps and all of that stuff goes into this model, and I'm expecting the user to just be very close to this model, right? So this distance going across the slide sort of represents the camera's draw distance. At the closest at the closest to the camera, I'm looking at my highest detail model at a certain percentage of the draw distance along the way, and I have control over where this is. I can have it really close, or I can have as many of these as I want too. I can have different steps along this distance where I'm swapping out different models. But I have a medium detail model where I have fewer polygons, lighter textures, because no matter how big the model is on the screen, the computer still has to do the same amount of work to calculate the materials and calculate, even if it's just drawing that same pixel over and over and over. Being further away from the camera does not make it any easier for the computer to process that model. So I swap out to a lower detail model when it's far enough away that I can't tell the difference anyway. And then when it goes even further away, where it's just a speck on the screen, I'm using a very low or absolutely no detail model whatsoever. It may just be a picture of the model. What's hard about this is a very difficult system to set up on your own because the models all have to match. You have to basically make the models at the same time. And that's what SpeedTree does because it procedurally generates the trees. It it makes it looks really good. You hardly see the popping as it goes from one detail to the other. And even in games like Grand Theft Auto or Assassin's Creed or any of these big open world games, if you look closely, you'll see the models change from one version to the other. You'll see as the higher resolutions pop in. And they do a lot to hide that, and you actually have to design the terrain a lot of times with hiding. hiding the LOD pops in mind, right? If it's just a big, broad, flat piece of terrain, it's going to be easy to see the waves of changing definition as you move closer or further away from them. There's some other interesting effects that you can do with level of detail, though, because these are just different models. I don't have to I don't have to put lower detail models in there. I could just put different detail models in there. So the rooftop where I had the workshop last year had a door at the back of the auditorium space that would open as you got closer to it, and as you moved further away from it, it would close. Um, Unfortunately, that effect only worked on the Quest for a reason I'm going to tell you about here in a minute. But what I was doing was, instead of different details, I had the door being open in different steps, right? So I had the door closed, door halfway open. I had another one with the door like three-quarters of the way open, and then a last one with the door all the way open. And these different levels were all just crammed one on top of the other. And as I said, this is a percentage of the distance of the draw distance, right? So at 0%, I was showing you, the door closed. 1% of the draw distance, you got the next model. 2% of the draw distance, you got the next model. And by 4% of the draw distance along, the door was all the way open. The reason that only works on the Quest and not the PC is because, and I don't have to come down here and look at the camera, it's just a camera. And what I want to see is right here. These clipping planes. All right, so another thing that computers do in computer graphics to sort of limit the work that the renderer has to do is they do these clipping planes. So I've got a near clip plane, and it's actually represented by this this little polygon here at the back of what's called this shape that represents what the camera can see is called the view frustum. So there's your word for today, frustum. All right, so the view frustum is the cone or the shape of what the camera can see, and it's got clipping planes on the front and clipping planes on the back. Now that's a thousand units away. I don't want to go all the way over there. And that's defined by the settings in my camera settings. If I set this down to 0, it goes all the way to the point of the camera, and sometimes this can give you really weird effects because you'll be able to, it will block your field of view, and it in a complex scene or a lot of stuff getting very close to the camera, it's easy to get lost if you get it all the way down to 0. And then my far clip plane shows me how far off in the distance I can draw. And a lot of times you'll see objects that are so far away that they clip out of the view and they go past this far clip plane, and you'll just see them disappear. They'll be clear 1 second and they'll disappear the next. And if you're building a world that's really, really big, if your view, if the things that I'm drawing is more than 1,000 units away, it can just clip right out of the world. But the strange thing is I won't see it clip out of the world on a PC. PC users won't see it clip out. That's because for some reason, AltSpace in their infinite wisdom decided to put the same near and far distances, or put different distances on the different platforms. So the Quest has, I think it's using the default. It seems like it's using the default. I don't actually know. Um, of a point 0.3 near clip and a 1,000 far clip. So the percentages of that distance that are swapping out the LODs are, relatively close. It's pretty easy for me to figure out. It's 1% of 1,000, 2% of 1,000, 3% of 1,000. The camera on the PC VR side of AltSpace, they've cranked this up to something more like 10,000. I guess it makes sense. PC users want to be able to see further away. They should have more powerful graphics, so they don't need the same, tender loving care from the LOD system. So let's let them see further, and let's let the LOD work further away. But that breaks that kind of special effect that I was trying to take advantage of, because now this distance, this relative distance, is 10 times further away than it is on the PC than it is on the Quest. The problem with all of these things, right? And this is where it gets tricky. This is where this can help you or this can kill you. Um, is the effect that these systems like terrain, LOD, and occlusion culling have. First of all, they really increase the size of the world. They increase the size of the data because an LOD group, it may perform better, but in terms of a data structure, it contains all of those models all the time. They're all in there all the time. And the same thing with the occlusion culling. Just because I can't see it and it's not being drawn, I still have to put it in the scene. It still has to get in there, and it's going to increase the weight of my world. Not only that, that occlusion culling, that data is another layer of data that sits on top of the template. Now it's not a lot. I think the occlusion data for that demo scene I was showing you was a half a meg. Oh, I've got that closed already. All right. Yeah, it was about a half a meg of data. But that half a meg of data that the occlusion culling system uses, that gets added to the template. As well as the logic of deciding which of these models do I need to show. How do I need to, the process that it goes through to decimate and retopologize the terrain on the fly, every segment. The occlusion culling, deciding, which cells can I see from the cell that I'm currently in. That's logic that actually does not get done by the GPU, right? So you're adding a lot of work to this logic segment here, and your video card's not going to matter because this is all done by the CPU. Now the intention is to reduce the work that these other things have to do, but I'm adding a lot of overhead just by implementing these systems. So you have to pay attention to the world that you're dealing with. Um, I was looking at Brex's world the other day, and do I still have? Maybe that was in my other Unity. Well, and he was working with this asset, or he was trying to get something done with this. It's beautiful. It's free, right? It's it's just but it's heavy, right? The package size is 700 megabytes, and you're not gonna be able to use all of it. But it's got particle systems, it's got plants, it's got fires. It is a man. It's everything. It's everything. But it's also really heavy. But I think that worlds built with stuff like this would really benefit from using something like occlusion culling to not show the heavy pieces of geometry. What occlusion culling isn't going to do, though, it's not going to reduce the size of the template. So if my goal is to build a world that's going to be featured or used with a main event, I'm probably not going to have any. I'm not going to have any use for occlusion culling. I'm probably not going to have any use for terrain because even if I got it to fit, even if I made a piece of terrain that was big enough, or let's say I had an occlusion culling scheme that was big enough to actually benefit from occlusion culling, there's no way I'm going to get it into alt space and have it as a featured event because it's got to be way too big before it starts taking advantage of it. And if I put occlusion culling on a world that's small enough to be featured or to be used as a main event, I'm probably really only going to see a performance decrease because of the extra logic I'm making alt space to. Does that make sense to everybody? Is that yeah? So it all depends on what I want the world to do, and there is if you want to see an example of this in action, and I haven't actually talked to the world builder about it. I wish I could because it's a really beautiful world. Let's see if I can find it really quick. Ah, I did find it. So, this world, and the code is UZK0023. You guys should go check it out because it's a beautiful piece of world building, and it does take advantage of occlusion culling because you can see the occlusion culling happening in the world. Unity, when it's doing the occlusion culling, doesn't know if a occluder is opaque or transparent or not. And so they've got some really nice rendered windows and some really nice windows effects, but the windows are being treated as occluders. So when I walk through a window and I'm looking through a window at stuff in the background, I can. But that's the only place in here where you see the occlusion actually happening. The rest of it's laid out very, very well. Um, so and they're not paying me to say this. I've never actually talked to these guys. I just was in this world the other day and said, "Wow, that's awesome." Another optimization trick. Wow, we're in 40 minutes and nobody's asked any questions. Am I just that good at explaining this? Um, so there's a number of different draw modes that you can use in the Unity editor to help you out when you're trying to optimize your scene. And this is one of the worlds that I did for the Mate virtual competition. And as I'm setting up my lighting and I'm looking to see how my UVs are looking, I can go over here and I can look at the baked light map view, which is going to show me only the shadows, right? It takes the diffuse off of all the materials, shows me only the shadows, and it shows me my texel resolution on my light map. So I can go through here and I can look and I can see what objects are getting too much light map attention and what objects aren't getting enough. And I can control that if I select any of these objects. Go to the inspector. Let me take a look at this one. When I look at the mesh renderer on any of these objects and I see its scale in the light map, that's sort of a coefficient that I can use to adjust the number of texels that are only on that object. So if I've got my light map the way I like it going across most of the terrain, and you're going to see this warning too. Object size in light map has reached its max atlas size. That means it's really big. That means the object that I've done, this entire stand over here, is one mesh renderer, which probably was not the best approach if I want to come in and manually adjust the scale in the light map. But if I've got a piece of geometry that the light map resolution isn't giving me the quality of the textures that I'm looking for, I can bump this up. I think up to like a maximum of 5, and that will, if I bump it up to 2, I'll get twice the light map texels on that object. 3 is 3 times the number, so on and so on. But I'll get higher detailed shadows just on that one object, and I won't be dramatically increasing the size of my lighting data across the rest of my world. And I get my best view of that with my baked light map view mode. The other one that I use a lot is overdraw. And overdraw will tell you what parts of your scene from any particular angle is the computer having to work the hardest to draw. So bright spots like the steps over that I did over there, those are actually the hardest thing in the scene for the computer to draw. Probably because I was lazy. Yeah, there's tons of faces in it. Yeah. So I was really lazy when I made this, and I took one piece of geometry and just boop, scaled it up, scaled it up, scaled it up, scaled it up, and made steps out of it. Right? And there's no reason for me to have faces on the back of each one of those, and certainly no reason to have faces on the bottom. So I could have really made that a lot lighter if I went into the editor. And same thing with this over here. But, there's certainly a corner that got cut. I could take those out and improve performance. So this overdraw mode will show you what parts of my scene are heavier than other parts of my scene, and this will have a noticeable impact as you're looking around different worlds. You look in different directions. You stand in different spots. Your frame rate is going to go up and down. When I was in Brex's Sun Temple the other day, if you stood in one spot and you look towards the center of the map, your frame rate just went to 15, 20 frames a second. I turn around and look away from the map, and it's back up normal. It's like, oh, okay, that's a good breath of air. But that's because the when the view swings around, and I don't even know what his overdraw map would have looked like, but it probably would have glowed like the sun. Because this really isn't that bad. If I was really hurting for performance, this is where I would probably want to focus first. This waterfall over here is also kind of heavy for the same reasons. I've got a bunch of faces in there that I just don't need. So even if I'm using occlusion culling, even if I'm, checking out things with my the overdraw mode, there may be places where the user can stand in the map where the performance is going to suck because they're able to see too much or the occlusion culling doesn't take anything out. And that's up to you now as a designer to find those places. Find those places and either eliminate those places where the performance is going to drop or prevent the users from getting someplace where they can see it to begin with. You know, probably a combination of the two approaches is probably going to work best for you. But you definitely want to be able to control where people go a lot of times in your world. Because remember the other day I was talking about the holistic sort of concentration, concentric approach to world design that I use, where I've got the skybox out here all around, and the skybox is a lot of times the most important, a lot of times the most important part of the world. I'll talk about that more in a second. And then I've got this setting space where I don't let the players go, and the objects there are very big, very low detail, and may or may not contribute to the global lighting. If they do, it's not going to be very much. But I don't let the players get into this because this is not only is it a place a lot of times where if they get there, the illusion of my world is going to fall apart. This is a peek behind the curtain, if you will. Um, so I don't want people going there. But these are also places where if you go, now I can turn and I can look back, and all of a sudden the entire world is in my field of view. Occlusion culling is not going to help, and it's just, my performance is going to suck if I let people get into this space where they can turn around and look back. Now inside of this space, I can have whatever kind of world I want to find. This can actually be a really big space. So I'm not saying you should avoid spaces or worlds that have like a flow to them. And sometimes based on depending on the narrative of the world you're trying to build, I may want to have a flow to it where you're intended to go here first and look at this, and then you're intended to go here next and look at this. And I use things like lighting or colliders or the shape of the floor, or sometimes I'll even put literal breadcrumbs down where lights light up as you're in the direction that you're supposed to go. You can do all sorts of stuff like that in this space, but you also have to keep in mind things like where am I putting my details. Even in here, can if I go to the far edge of this, what's my performance going to be like? And then when you're testing this space out, it's on you as a designer to go in here and try to get to these other spaces and see where are the trouble spots in your world based on the performance. Find those spaces and figure out what it is that's causing your performance issue and take those things out. Now, as I said a minute ago, I personally believe that the skybox is possibly the most important element in a world, um, because it does so much, and not just in terms of the lighting, but it informs the user about the broader setting of the world, right? I can make the world look infinite. I can make it look big. I can make it look small. I can make it look minuscule. I'm designing one now that I want to be inside of a drop of water from like a lake. So it's going to have that algae and amoebas and just all sorts of microbes, whatever nasty things you don't want getting in your ears or up your sinuses. But all of that's going to be in the skybox. So this it doesn't necessarily have to be a sky. It could be the roof of a cavern. I've done skyboxes that represent the inside of a cave, and as long as I don't let the user get to a point where it becomes apparent that it's a skybox, it really works as the roof of a cave. It all depends on the setting. Wow, and I'm almost out of time. I thought I'd so six-sided skybox. How do I build a six-sided skybox? I build mine in 3D Studio Max, but any application, even Unity, you can make one of these in Unity, if you want to. But anything that allows you to control the aspect ratio of the camera. The important thing is that I have, and you could do this with one camera that moves. I've seen that approach too, but I've got six cameras, and they're labeled front, back, left, right, up, down. And each of the cameras have a 90-degree field of view and a 1:1 aspect ratio. So they will produce square images, and when I render out all six of them, they will form a seamless six-sided skybox. I take that over into Unity, and that's what I use for my skybox because I get six times the texture resolution that I can from a normal skybox, either that uses like a panoramic photo. Um, Certainly higher resolution than the skyboxes that you get from AltSpace under the world building tools, and that allows me to get a lot more detail into my wow, am I asking too much of this machine? It allows me to get a lot more details into my skybox. I'm going to close this instance. Dual Xeons and 32 gigs of RAM, man. You got three instances of Unity, an instance of 3D Studio, OBS, PowerPoint, Photoshop. I love computers. All right, so let me look at my project, materials. Man, I should have just done this. So here's a good skybox. And if I look in the inspector, I see the slots where I can assign. These are the images as they come rendered out of 3D Studio. I just drop the right image into the right slot, and Unity stitches it together into a very high resolution, seamless environment. The one thing that you want to now these are big. These are big. Um, they're big pieces of texture information, right? So typically they run usually about 6 or 7 megabytes, about a megabyte per side, and that's going to be on top of your template, right? So if I'm trying to squeeze it within, that 20 megabyte absolute hard limit, I've really only got 13 megabytes left for lighting data, textures, and materials because 7 of that's going to be taken up by my skybox. Um, but a lot of times I'm okay with that. Several of my worlds, I have put more work into the skybox than I did into the rest of the template. All right, so there's a bunch of stuff I forgot to talk about, or just didn't have time to talk about, or here's a list of stuff that I haven't even had a chance to try yet in Unity. Um, or I've tried it and I couldn't get it to work. I want to come up with a shader that is for a six-sided stereo skybox. So I can have stereo skyboxes, and I can have stereo VR video as a skybox, and Unity supports it. They're awful because the resolution just sucks. But I'm trying to come up with a way where I can, instead of giving it 6 images, I can give it 12 images rendered from a stereo pair of cameras, and so I get a stereo separation in my skybox all the way around. I'd love to get that working. Um, I'm trying to write a shader where I can get refraction and volumetric fog to work underwater, right? So if I'm looking through the surface of water, I can see the objects underneath and they're affected by refraction and volumetric fog under the water. That's something else I haven't gotten working yet. Audio mixers, I haven't tried an audio mixer, but audio mixers are things that are in Unity, and as far as I can tell, they don't use any scripts, and I can work with them to create weird audio effects from my audio sources. Audio's not my strong suit, though. I get lucky most of the times with audio and don't actually know what I'm talking about. Compute shaders, I think, are potentially possible in alt space if you bring them in just right. Normally, a compute shader is activated and controlled by a script. We have no scripts in here, but I think there may be a way that I can summon a compute shader from a material. It works on the whiteboard. I've never tried it. Same thing with scriptable objects. If I'm trying to if I'm trying to make a bunch of similar things that are all a little bit differently, but they have a lot of the same things in common, like say insects, right? I can have a group of insects, and I can have a type of insect that's ant, a type of insect that's beetle. Insect would be could be a scriptable object. It's not a script, you know, but it would, from a world building standpoint, it would give me a lot of flexibility if I wanted to do some elaborate. In certain use cases, I think it would be handy to have. Anyway,
Mark,
yes,
drum roll, we have a question.
I see that. Okay,
Are you ready? Are you
yeah,
ready?
hit me with that question.
Chuck, Chuck, you're up.
Okay. Can you hear me?
Yes.
Yes.
Okay, super.
Well, now I can't hear you.
Hang
Oh, yeah. Okay.
Last thing I heard
Yeah.
was
So
super.
I've not used the six-sided, and I think I'm usually using like the equirectangular. All right.
Yeah.
But I understand you can. There's ways of converting back and forth. I'll often want to edit a skybox, and so for example, we're outside of a convention center, and there's a sign up there, and I go, I want to change the lettering on that sign to be whatever my meetup is about. Uh, but what I have to do is open up the equirectangular in Photoshop, and then I've got to just distort my text so it kind of matches. Whereas I'd really like to do is just be in a kind of a more 360 view and just look at directly onto that sign and edit it more naturally. Second thing is, second question had to do. I forgot my second question, but go ahead on that one. Oh, I remember.
So,
My
okay,
just
go
a
ahead.
second. The second question is, okay. I've often procedurally generated a lot of content in my worlds by running scripts at edit time. And so I have a folder with like 100 screenshots. I'll just loop through that while creating objects, and then at the very end, of course, you have to delete the script, and then you can upload. And so you can kind of procedurally generate a lot of content that way. And I just wonder if you've tried that, or whether it's a, I don't know if that idea is something that can be elaborated and extended and a good direction to go or not.
Well, it certainly is, right? That is an entire topic that didn't even mention is that Unity supports scripts that run in the editor while you're editing. Um, the Unity engine, the editor is written in the Unity engine, and when I'm working in a world in Unity, Unity is running all the time. So I can write scripts that won't be part of the template, and they won't come into alt space and flag my template, but they do all sorts of utilities while I'm editing the world, just like what Chuck is talking about here. So yeah, depending on the use case, I do use a lot of those stuff. An example of that is the Unity uploader itself from AltSpace. Is it's an editor script, and it uses Unity, the engine itself, to bundle this stuff up. Um, on your first question, Photoshop does have a 3D drawing mode where you can take that 360 image. It depends on which version you're using, because I don't think it existed before like 2018 or so. But you you can sort of wrap it around the inside of a bubble and scroll around in different directions and draw on it as if it's flat. But off the top of
And
my
is
head,
that the way you do it?
no, no. Well, I usually don't have to edit 360 photos because I generate them
Okay,
all myself
so
in
let's.
something like 3D
I'll give you
Studio.
so you were talking about the example where you're in the water, and let's say you want a fish. If you drop that fish on one of those 6 square pictures,
Hmm.
won't that fish be distorted?
Yes, it would. What I would do instead is
Okay.
I would put the fish into 3D Studio and re-render the skybox.
Uh, okay.
Yeah, that's the key, is you need to have access to some sort of package that allows you to set up that camera rig and take those pictures. Now, Unity can do this. I could make a set of Unity cameras and I can make my Unity scene, and I can put anything I want to, any assets. I can make it as big as I want to. Once I render those images, I don't need that anymore. I can take
Yeah.
those images and make my skybox in my actual template project. My skybox project can be hundreds of megabytes, gigabytes. I don't care, right? Because I can be patient with that.
So in other words, the way in which you are creating your skybox is creating a 3D world, going into that 3D world and taking a picture in all directions, and then exporting that or capturing that for use as your skybox.
Exactly. Yeah,
Okay.
I probably should have zoomed out on this earlier, but this is one of the skyboxes that I've done before. And I mean, it's so much geometry and it's so big that my computer is just losing its damn mind over trying to draw it. But it'll render just fine. It takes about an hour to render each one of these frames. So I usually set up a macro to run through all that and let it go. All right, we are out of time. Um, I want to plug the Discord one last time as we wrap this up. Right, get on the Discord, and I've got a channel up there for you to share your worlds, ask questions. One thing is make sure that your universe and the world is set to public, otherwise I won't be able to get into it. And you don't have to list it for the first part of the week, but it would be best for the event next week that it is listed. Um, and that's wow. I can't believe we're at the end of this. Lorella, you got anything you want to say to wrap this up?
Well, yes, I do. First of all, we need some applause for Mark Gill here, Carnivore, for this incredible week long series of just, I'd say mind numbing, but that's not even close. This is brave and beautiful and wonderful stuff. You had the courage to take on alt space and say this sucks, and you're just amazing, amazing stuff. This is absolutely beautiful. So thank you so much for all your generosity of spirit and courage to stand up here and help us understand how do we make our worlds better? How do we really do play the voodoo that you do? How do we do that? So thank
Gosh,
you.
that's thank you. That's really nice to say. But if everybody knew how much fun this was, everybody would be doing it. I swear.
That's true. I love it. I love it. All right. So this has been another Univirtual experience as part of our conference all month long in May with Virtual World Society and Educators in VR, collaboration that brings together experts and innovators in immersive education that are disrupting education around the world. And you just witnessed some of that disruption right here. So thank you so much, Mark, for Carnivore and everyone, our film crew and our moderators and everyone for making this such a success. Also want to thank our sponsors. Remember, our sponsors help us to manage this financially as well as with in-kind support, or this would not be possible to do this for free. So we want to thank HP Virtual Reality and HP Higher Education, our Infinity sponsors, our Galaxy sponsors, Engage and Advantis Education, who are absolutely changing the face of education with immersive technology. Also, our stellar sponsors, Grove XR, the VR Lady, Frame VR, Learn Bright, LBX Immersive, and Waking Dream XR. And Donna McTaggart of Let's Meet in VR, the event manager and director for Educators in VR and Universal Experience. We have an event coming up next week where Donna and I are going to be talking about how do you do conferences like this? How do you do events in VR? So get ready for that. Now, we also want to remind people to get into the Discord. Do you want to put that back? Are you going to do a video or are you going to, what's,
No, I
okay?
hang on a second. Yeah, I
Okay.
fat fingered
Oh, you had
closing
that
the.
up? Make sure if you are not in the special Discord that is closing today, right?
Um, well,
You're
the
going to give at
funky
least the
look.
weekend?
Yeah, hang on a second. Yeah, it's actually going to be up. Oh, I got to go back to the web player to start it.
Oh,
It's
that's
actually going to
fine.
be up the
That's fine.
rest of
All
the
right.
week, right? The URL that I had set up for the.
Okay. It's discord.me/carnivore with a K. There you go. Carnivore
Yeah,
with a K for those that can see that.
yeah. The other
And
URL did expire, but that one is still good.
okay, all right. So that one is still good. And so please check that out and get in there right away before it closes up. The uh, showcase. Tell us about the showcase
Um, Oh, the tours that we're
next.
going to be doing next week. Yeah, so we're going to be
Yeah,
we're going to be taking your worlds, right? I want you guys to do the stuff, take the stuff that we've covered and the ideas that I've given you, and some of the techniques that I've shown you, and it doesn't have to be magic. It doesn't have to be complex. It doesn't have to be we're not going to get scored or graded. It's not a competition. Um, but I do want to see the kind of creativity that you guys can come up with given a week. The Discord has it's got videos, it's got tutorials, it's got references. It's it's a group of people who all want to get there and build worlds and help each other build worlds.
beautiful. So get ready for that. So thank you, everyone. The filming will now end. All right. Thank you again to all of our moderators, our team with Educators in VR and Virtual World Society for helping to support this. And Mark, you're going to have a few minutes to hang around for just a little bit?
Man, I am 6 minutes late for a hard 10 o'clock.
Okay. All right. So he's on his way, but do join him in the Discord and you'll get your questions answered. So thank you, everyone, for being here. Our next event started 6 minutes ago, and it is the critical evaluation of 7 immersive VR platforms for language learning and education. So you do not want to miss that. So hop on in over, and we have a whole ton of it for the universal experience continuing today and throughout the rest of the month. You can find the schedule at educatorsinvr.com. Thank you,
Yeah.
Mark.
I would stick around and answer questions, but I do have to go. So, ladies and gentlemen,
Yep.
Carnivore has left the building.
Yay! Yay! And I'm hopping to the next event. You're welcome to stay as long